today under the concept that is basic principles of organic chemistry. Under that specifically we are going to see the types of reactions in which we have a sub classification. You can take it as a bond fission, which leads to the types of attacking species reagents, and then followed by the reactions. First, see, let us say a molecule like AA, when it breaks in the center, so that you get the two pieces of A having a one free electron, such species are called free radicals. Free radicals. The breakage is called homolysis or homolytic fission. Homolytic fission. This is very commonly takes place in the organic chemistry. Several times either the atoms are same or the less difference in the electronegativity leads to this type of the breakage. When a molecule like AB breaks unevenly, so that one atom or one group gets a positive charge, the other one becomes into a minus, they are called cation and anion. However, these cations and anions in the organic chemistry we classify as a electron deficient, so therefore they are called electrophiles. Electrophiles means electron philic reagents, electrophiles. The other one are called nucleophiles. The type of the reaction is called heterolysis or heterolytic fission. Heterolytic fission. So there are basically there are two types of fissions in the organic chemistry. Center breakage leads to the homolytic fission and they form the free radicals. Uneven breakage makes cations and anions, which are in turn called electrophiles and nucleophiles. However, electrophiles can be three types. All cations like A plus, okay, all cations, you can take any cation is nothing but the electrophile. However, there are some molecules which are having vacant orbitals like aluminum chloride, anhydrous aluminum chloride. This is second type of the reagents like BF3. These are the second type of electrophiles. They have no charge, but they have a vacant orbital so that they can grab the pair of electrons and make the bond formation. The other type will be the molecules which are containing hetero type of the bond, which breaks into plus minus and this place acts as a potential cation. So there are three types of the electrons. Similarly, the nucleophiles also can be classified into the three types. All anions like a B minus, okay, all anions are nucleophiles, and there are neutral molecules like water, ammonia, and so on. They have this vacant orbital, but they have a pairs of electrons on the molecule, so which are called nucleophile. They no charge neutral molecules with pairs like water, ammonia, substituted water, substituted ammonia, and so on. This category type, third category is the molecules which have got a CC double bond like alkenes, CC triple bond alkynes and benzene and so on, where this type of homo type of the multiple bonds molecules are called nucleophile, because the bond is loose, electrons are available. So nucleophiles, they are donating electrons and makes a bond, so therefore they are called nucleophiles. So there are three types of this species, attacking species. Free radicals, we have a one unpaired electron. Electrophiles, electron deficient species. Electron excess species are called nucleophile. These are the three types of the attacking species. Now basically the types of reactions which involves these type of the attacking species. Reactions can be basically again three types: addition reaction, substitution reaction, elimination reaction. Okay. Addition you can classify as an ethylene plus, for example, if you take HCl, H will be added one side, Cl will be added one side, so you will get a single molecule, ethyl chloride is formed. This is an addition reaction. When a substitution, if you take a methyl group containing this hydrogen, if it is replaced by a chlorine atom, in the place of hydrogen, one chlorine if it comes, you will get a methyl chloride, right? and this H and Cl will goes out as a HCl. So, what happened in our molecule is one hydrogen is replaced by a chlorine. So, therefore, this is called a second variety substitution reaction. In the elimination reaction, we have one hydrogen and Cl. These two groups, if they are removed as a HCl, so that a alkene is formed, and this HCl in general we use a concentrated base, so that this acid and base will neutralize to get a water and the KCl. So, the molecule becomes a unsaturated, saturated will become unsaturated, the two side by side groups are removed, this is called elimination. So, addition reaction means A plus B becoming C, unification. Whereas, from the group if you remove and you will get answer, this is exactly to reverse, addition and elimination reverse. In the substitution, one new old group is removed and a new group is coming, substitution. Now, this addition and specifically the substitution again divided into the three types. By in this, for example, if alkenes if you take, alkenes are rich with electrons because the pi bond is loose enough. So, first electrophile will attack first, not the nucleophile, because the nucleophile, this is electron rich and this is electron rich. So, first electrophile will attack. Therefore, the alkenes undergo electrophilic addition reaction. Examples are alkenes and alkynes. These two molecules undergo electrophilic addition reactions, and in the addition it can be a nucleophilic addition reaction also. The carbonyl compounds undergo nucleophilic addition because the reason is they also have a double bond, so therefore undergo addition, but among this C plus and O minus, C plus is more reactive. So, therefore, first nucleophile attack. So, aldehydes and ketones undergo this type of the reaction. Both aldehydes as well as ketones undergo this reaction. Now, the third type of addition is a free radical addition reaction. This is takes place in alkenes once again, catalyzed by the peroxides. When peroxides are there, again alkenes and alkynes undergo this same free radical addition reaction, because under this peroxides the reagents will be available in terms of the free radicals. Therefore, one of the free radical add one side, the other free radical add on the other side. Now, similar the way the substitution is also further classified into the three types: electrophilic substitution reaction, nucleophilic substitution reaction, and free radical substitution reaction. In the electrophilic addition reaction, benzene is the best example reaction. Benzene will have a electron richness, so only the electrophiles will approach. Afterwards, one of the hydrogen which is there outside the benzene molecule will undergo a substitution, because the three double bonds will be rotating and they are under resonance called aromatic feature. So, therefore, they do not want to undergo addition, but substitution is preferable. Under the nucleophilic substitution, alkyl halides undergo this type of the reaction, because the X bond is polarized, you will get a plus charge on the alkyl group partly. So, nucleophiles are susceptible to attack on the alkyl. So, replace the halogens subsequently. So, new group will be entering into the X place. So, therefore, they are called nucleophilic substitution. Technically, this is also in the, with reference to the kinetics, we have a substitution nucleophilic bimolecular, substitution nucleophilic unimolecular. SN2, SN1 is the further classification based on the how many molecules or pieces are involved in the rate determining step. We have a further classification. Free radical substitution is under the alkanes. We have this type of the reaction. All alkanes, AN. To reflect the alkanes. So, this alkanes will undergo this free radical substitution, because the molecules which are neutral will undergo only the free radical attack. After that, they are saturated, therefore, they show only the substitution. Therefore, free radical substitution is the characteristic reaction of the alkanes. Now, come back to the what type of compounds. Alkenes, alkynes undergo electrophilic addition, alkanes undergo free radical substitution, and the benzene undergoes electrophilic nucleophilic substitution, halogen compounds nucleophilic substitution, aldehydes and ketones undergo nucleophilic addition, and enes and alkenes and alkynes under influenced conditions with peroxides undergo free radical addition. These are the main characteristic three types of the reaction. However, elimination is again a characteristic reaction in the alkyl halides and the alcohols shows this type of the elimination reaction, which leads to actually unsaturated compounds become into unsaturated. It's not a favorable reaction, but under particular conditions like a concentrated alcoholic KOH, and by heating by forcefully the saturated compounds will become into the unsaturated compound. This is not a favorable reaction, but still the molecules like the groups which want to go out, that is outgoing property. Whenever outgoing property is there like halogens and the alcohols, this type of the compounds shows a nucleophilic substitution.